Hi friends, welcome to the Unit 3 Day 2 video. This one's over synthetic division, the remainder, and the factor theorems. This starts with an application introduction. If you think about like a river and how the water flows, you would want to be careful about how fast the water is flowing out of the river and also flowing into the river. So this one talks about the discharge rate of a river, and in this one, this particular kind of equation that it's set up, this is thousands of cubic meters of water per second. So we're talking about a very large amount of water that's discharging from the Shimote River. We're going to talk about this at the very end, but I just kind of wanted to show you that this is a very nice real-world polynomial example. Most of the polynomials that you would analyze in the real world don't necessarily look as clean and as nice as this one does. This one is one that the textbook gave, but I believe wholeheartedly that a real-world example just doesn't look this nice. And the the approximation here where it says in thousands of cubic meters, that's telling you that it's a lot going on here. It also talks about where M is the month, and then 1 is January, so then 12 would be December. So for the domain for this one, we're talking about domain in the months from 1 to 12. In this particular scenario or instance, you wouldn't have values of 0 per se, you wouldn't have values of 13, just those months. So we're going to talk about that, but we're going to hit that towards the end of the note. So I just kind of want to introduce that now. Back in elementary school, you learned long division. And I just want to go over an example of a long division problem before we actually get into the long division part of these particular notes. You probably did long division also in an Algebra 2 course, and synthetic division as well. It may have been called synthetic substitution. Synthetic substitution is slightly different than synthetic division, but the idea and the process and the end result are very similar. So let's just talk about long division that you did back in elementary school. If I wanted to take 6 divided into, let's talk about 43. So what I would do in this process is I would think, okay, 6 goes into 4 0 times. So 6 doesn't go into 4, so I can't actually put a number above that. That's important that we talk about this as like the place value. 6 goes into 43 7 times, because 6 times 7 is 42. After we multiply it through, so we take 6 times 7, notice that we're lining it up vertically, so this entire column stays in line. This 7 times 6, so my 1 spot will go here, this is my 10 spot, and then I subtract this entire thing. It's important, I'm drawing attention that we're subtracting the whole thing. We're not just subtracting just the 4, we're subtracting the 42 from 43. We're left with 1. Your teacher may have asked you to put a 0 here and then bring down the 0. That's for converting it to a decimal answer. Note that right now, this answer as it is, we are actually given a fractional answer. So 6 goes into 43 7 times. And you may have remembered that they talked about this 1 as a remainder 1. And the reason that they called it a remainder is because you had 1 out of 6 remaining, so 7 and 1/6. And 7 and 1/6 is the mixed number of the improper fraction 43 divided by 6. These two are mathematically equivalent. A lot of students get confused when we say division is the same as fractions, fractions the same as division, they're just another way to represent them. So this idea and this concept we're going to hit as we talk about long division and synthetic division. I'll see you in that video.